one of the most important implications of the Heisenberg uncertainty principle is that it rules out existence of definite path or trajectories of electrons and other similar particles. So what does it mean, trajectories? Suppose you have a car to move from this point, and after certain times you reach at the B point. So if you know this position A, this position and its velocity, then you can measure precisely that when it will come to the point B at what velocities. That means if velocity and position if you know correctly, then you know that after some times where this car will be. This is called the trajectories, or this is the definite path. That means the trajectory of an object is determined by its location. In this case, I put A, and the velocity. If you know the location and velocity, then by mathematical calculation, you can precisely will know at what time, at what place that car will be. If we know where a body is at a particular instant, and if we also know the velocity, then the force acting on it at that instance, we can tell the body would be sometimes later at which place. Okay, so in that way we can conclude the position of the object and its velocity to fix its trajectory's position. But for subatomic objects like electrons, it is not possible to determine the position and velocity at any given instant, as per the Heisenberg's uncertainty principle. That means you will not get the position and velocity at certain instance with arbitrary degree of precision. With precision, you will not get the position and velocity of this type of subatomic object, as for example, the electrons. The effect of Heisenberg's uncertainty principle is significant only for motion of microscopic. Microscopic means very small. That means subatomic objects, as for example, electrons. But this uncertainty principle will not be applied for the macroscopic object. That means heavy object. Tell about the macroscopic object, that means heavy objects. So when the object's weight is in a milligram range, then it is called the macroscopic object. So what will happen in that case if we apply the uncertainty principle? You see, this is the equation. This equation I already described in the previous class number 26. If you did not see this, please go and check that class. So here the M will put 10 to the power minus 6 kg. So here we put the value, then ultimately the value will come 10 to the minus 28 per meter square per second. That means it is very small. It is very small because 10 to the minus 8. 28. So in this case, this value is negligible. That means delta V denotes for the uncertainty for velocity, and delta X denotes the uncertainty of the position. So that means this is very negligible, because this value you see the 10 to the power minus 28 per meter square per second. And so for the macroscopic objects, this uncertainty principle will not be applied. It is written there clearly. Now we'll discuss about what will happen for the macroscopic objects if we apply the uncertainty principle. So macroscopic objects means it is very, very, very small object. As for example, you take the mass of the electron, that is the constant value 9.11 multiplied by 10 to the minus 31 kg. So similar way in this equation, this m, this will replace by the value 9.11 multiplied by 10 to the power minus 31 kg. Then you can see the ultimate what is the value. This is the 10 to the power minus 4 per meter square per second. So this value will be accountable. That means it is much, much greater than the previous value for the delta V delta X of the macroscopic object. So in this case, this value is much more. That means delta V dot delta X, this value is very significant. Okay, so for the macroscopic objects, this uncertainty value is much more. So what will happen? In that case, that means the Heisenberg's uncertainty principle will be applied. You can see that one tries, that means if you try to find the exact location of the electron, then the uncertainty value will come 10 to the power minus 8 meter. Position, so position will be denoted by the meter. So uncertainty of only 10 to the power minus 8 meter. And then what is the uncertainty in case of velocity? Then it is the 10 to the power 4 meter per second. This value is very, very high. Very, very high value. So that means here the delta V is so large that that classical picture of electrons moving, whatever we understood from the Bohr's atomic model, Bohr's orbit, it will not be applied for the subatomic particle, especially for the electron. And this is the significance of the uncertainty principle, Heisenberg's uncertainty principle. Conclusion, what we can tell? Now we understand that the precise statements of the position and momentum of electrons, you have to remember always, electrons, that means subatomic objects. That means objects has very, very, very less mass. And then in that case, this term will be replaced by the term probability. And with the help of the statement of probability, that means it is not the precise, whatever we understood from our previous discussion, that the electron has at a given position and momentum. this is what happens in the quantum mechanical models of atom. That means for electrons or any subatomic objects, only if you want to locate the position and momentum, that you will find some probability of it in certain position. I hope that you understood very clearly about the significance of the Heisenberg's uncertainty principle, and also you understood that what is the calculations for the macroscopic objects for the position and velocity to understand, and as well as for the microscopic objects.